If you could have one superpower, just one, what would it be? Flight? Super strength? Invisibility, maybe?
I feel like if people were being totally honest and we put aside the whole flying around in a cape thing, most would choose a crystal ball.
Oh, absolutely. Just the ability to know what happens next, whether it's knowing if it's going to rain on your wedding or, I don't know, which horse wins the Derby.
Or, more practically, where the stock market is going next week.
Mhm.
We are just obsessed with certainty.
It's a universal thing. We hate the unknown. But here's the thing. While you might want that crystal ball for your personal life, in the business world, seeing the future isn't a fantasy. It's a matter of survival.
And that's exactly what we're getting into today.
We are doing a deep dive into the crystal ball of business, specifically Chapter 9 of our source material titled Forecasting Methods.
And before you tune out, because forecasting sounds like, dry statistics, let me just raise the stakes here.
Yeah.
We aren't talking about guessing numbers in a spreadsheet.
Right.
We're talking about whether a company has enough inventory for the Christmas rush or if they've wasted millions on products that are just going to sit in a warehouse.
Yeah, let's unpack that right away because the source material mentions some pretty startling stats about the cost of poor forecasting. It's not just an inconvenience, it hits the bottom line hard.
It does. The text cites a study from the Aberdeen Group, and this really drove the point home for me. They found that companies with forecast errors above 10%.
Which, by the way, isn't even that big of a miss.
No, not at all. That's a pretty standard margin of error. And for that, they experience 15% higher inventory carrying costs.
Wait, hold on. 15% higher costs just for holding on to stuff?
Exactly. I mean, think about what carrying cost actually is. It's not just the price of the item. You have to rent the warehouse. You have to pay for the electricity, the insurance.
And if it's something that goes obsolete, like a smartphone, it might just become worthless while it sits there.
Right. So that 15% eats directly into your profit margin.
That makes sense. It's the cost of clutter, but on a huge corporate scale.
And the text mentioned a hit to customer satisfaction too, right?
Right. The flip side is under forecasting. You guess low, you run out of stock. The study showed a 10% drop in customer satisfaction for those same companies.
Because if you don't have it, I'm not waiting, I'm going to your competitor.
Precisely. And you might not come back. So it's a double-edged sword. Guess high, you lose money. Guess low, you lose customers.
So our mission for today's deep dive is to figure out how to walk that tightrope. We're going to demystify two fundamental ways businesses try to predict the future. And I have to be honest, when I first read the names of these methods in Chapter 9, I actually laughed.
I think I know which ones you're talking about.
I mean, come on. The first one's called the naive method, and the second one is simple moving averages. It sounds like we're bringing a plastic knife to a gunfight here. Naive and simple.
Can these really save a company millions? It sounds totally counterintuitive, I know. We expect complex problems to require, AI, neural networks.
But often, complexity does not equal accuracy. Sometimes, the dumbest tool is actually the sharpest one.
Okay, I'm intrigued. But before we get to the methods, we need to understand the raw material. The text talks about time series data. Can we just define that so we're all on the same page?
Sure. It's pretty straightforward. It's just data collected at regular intervals. Daily sales, weekly shipments, that kind of thing. It's a movie, not just a snapshot.
And the text says when you look at that movie, you're looking for a story with 4 parts. Let me see if I've got this. First is a trend.
Right. Is the story going up or down? Are we selling more laptops this year than last? That's your trend.
Then seasonality. That's the stuff that repeats, like selling more sunscreen in the summer.
Yep. Short-term repetition. Every year or maybe every week, like a restaurant being busy on Fridays.
Okay, then there are cycles longer-term things like economic booms and busts. And finally, the villain of the story. Random variation.
Or noise. This is the unpredictable stuff. A celebrity tweets about your product, sales spike, or a blizzard hits and sales tank. It's the blips that don't fit the pattern.
And this noise is the enemy of the forecaster, isn't it?
It is. The goal isn't to predict the future perfectly. You can't because of the noise. The goal is to separate the signal from the noise so you can be proactive instead of reactive.
Proactive versus reactive. That's the key. So let's get into our first tool for being proactive, the aptly named naive method.
The naive method.
Talk to me about this, because calling a business strategy naive sounds like you'd get fired.
You might think so, but in this context, naive just means uncomplicated. The philosophy is beautifully simple. The best predictor of tomorrow is whatever happened today.
That's it. That's the whole algorithm.
That's the whole formula. F of t plus 1 equals a of t. The forecast for the next period is just the actual from the current period.
So if I sold 100 coffees today, the naive method says I'll sell 100 tomorrow.
Exactly. And if you actually sell 105 tomorrow, well, then your forecast for the day after that immediately becomes 105.
Let's walk through the ABC Electronics example from the source just to see the mechanics.
Okay, so ABC Electronics tracks monthly laptop sales. In May, they sold 480 units.
480. So using the naive method, the forecast for June is, what, just 480?
It's 480. You just take May's number and paste it into June. No math, no adjustment.
Simple enough. But then the actual numbers for June come in, and they sold 495 laptops.
Right, so our forecast was off by 15. But here's the key. As soon as we know June was 495, that immediately becomes the new forecast for July.
So the model has zero memory. It doesn't care what happened in January or February.
No memory at all. It lives entirely in the moment. It assumes the most recent data point has all the information you need.
This brings me to my aha moment from the reading. Why would anyone use something this basic? It feels lazy. But the text makes a great point. It's a benchmark.
That is the single most important takeaway. Think of it as the baseline. If you hire data scientists, buy expensive software, and your fancy model can't beat tomorrow will be like today, you are wasting your money.
If you can't beat naive, go home.
Exactly. It forces you to prove your complexity as value. And in stable markets, it's actually very hard to beat.
But, and there's always a but, it has a fatal flaw. We saw it in that electronics example.
We did. The sales were trending up. May was 480, June was 495. Because the naive forecast is always looking backward, it was consistently underestimating demand. It was always lagging one step behind.
It's like driving while looking only in the rearview mirror. You see the curve after you've already missed it.
That's a great analogy. And it also highlights the problem with relying on just one data point. What if yesterday was just weird, a random spike or a dip?
Right, you end up chasing ghosts.
Which is the perfect setup for our second contender, the simple moving average, or SMA.
The SMA. So this tackles the noise problem.
It does. Instead of betting everything on yesterday, we say, let's look at the last few days and just average them out.
The source material uses the term sliding window, which is a great visual.
It really is. Imagine a window frame that captures just the last, say, 3 days of data. As a new day arrives, the window just slides forward one spot. You drop the oldest day and add the new one. It smooths everything out.
Let's use the coffee shop example from Chapter 9. It shows the math really clearly.
Okay, so the manager wants to forecast sales for Sunday. They decide to use a 3-period simple moving average. So they look at the 3 days before Sunday.
Thursday, Friday, Saturday.
Right, so data.
Yeah.
Thursday was 242 cups, Friday 255, and Saturday was a big day, 268 cups.
Now, if we were using the naive method, we'd have just grabbed Saturday's number, 268, and said Sunday will be 268.
Exactly. It would assume Saturday's spike was the new normal, but maybe a tour bus just stopped by. The moving average is more cautious. It adds them up. 242 plus 255 plus 268, that's 765.
Okay, and then divide by 3.
And you get an average of 255 cups.
So the forecast for Sunday is 255. It balanced out the low Thursday and the high Saturday to find that middle ground.
Precisely. It smoothed out the variation. It gives you a much more stable number to plan around.
Okay, but this brings up a new problem, a kind of Goldilocks problem, right?
Exactly.
How do you pick the right size for that window? The example used 3 days. Why not 5 or, I don't know, 7?
Or 30.
Yeah.
Yeah, this is the million-dollar question in forecasting. Choosing n the number of periods. And it's a strict trade-off. There is no one correct number.
So let's break that down. What happens if we choose a small n, like a 3-day average?
With a small n, your forecast is highly responsive. It reacts really quickly to new information. If sales jump, the average jumps pretty fast. You want this if your market changes quickly.
But the downside is volatility.
It can be jumpy. It might overreact to that noise we talked about. A single random spike pulls your whole forecast up.
Okay, so let's go the other way. We use a massive n, like a 12-month average.
A large n gives you it gives you a very smooth line. It filters out almost all the noise. It's very stable. Great for something like toilet paper sales. But it turns like a cruise ship. It's slow to react.
A cruise ship versus a jet ski. That's the idea.
Exactly. The jet ski is the small n. It turns on a dime, but it's a bumpy ride. The cruise ship is the large n smooth sailing, but you can't turn quickly. If your sales suddenly take off, a 12-month average will lag way behind reality.
So the framework is small n for speed, large n for stability. You have to know your data.
Spot on.
Okay, so we have 2 methods, naive and SMA. But how do we know which one is actually working better? We can't just go by vibes.
No, in business, vibes get you fired. We need a scorecard. And in forecasting, that means calculating error, and error is just actual minus forecast.
How far off were we?
Right. And you can't just look at one day's error. You have to aggregate them. The source material highlights 3 ways to keep score.
The first one is MAD. MAAD, mean absolute deviation.
This is the most intuitive one. Absolute. Just means we ignore whether we were over or under. We just care how big the miss was. MA tells you, on average, how many units are we off by?
Simple. On average, we miss by 5 laptops. But sometimes being off by a lot is a disaster. That's where MSE comes in. Means squared error.
Mm-hmm. This one brings back some high school algebra memories.
Squaring the errors. Why do we do that?
To punish the big mistakes.
Hmm.
Think about it. If you're off by 2 units, 2 squared is 4. Small penalty. But if you're off by 10 units, 10 squared is 100. The penalty grows exponentially.
I see. So if I'm running a hospital, missing by 1 bandage is fine. Missing by 100 is a catastrophe. MSE screams at you when you have those big misses.
Exactly. It says, I'd rather be wrong by a little bit every day than wrong by a huge amount on one day.
Got it. And the last one is MAPE, mean absolute percentage error.
This just helps you compare different things. If I say the error is 100, is that good or bad? If you sell 1,000,000 units, an error of 100 is amazing. If you sell 200 units, an error of 100 is terrible.
So MPE puts it in a percentage. We are off by 3%. That's universally understood.
Precisely. It levels the playing field.
Okay, we've got the contenders and the scorecard. Now for the main event, the showdown, the naive versus SMA case study.
This was my favorite part of the chapter because the result is genuinely surprising.
So let's set the scene from the text. We have a retailer with monthly sales that are trending straight up.
Right. A nice clean growth trend, 115 units, then 120, then 125.
They run the numbers using the naive method, and they calculate the MAD, the average error. For naive, the MAD is 6.67.
Okay, remember that number? 6.67. That's the score to beat.
Then they run a 3-period simple moving average on the same data, the smarter method, and the MAD comes out to 10.57.
Wow. That is a significant difference.
It is. The dumb naive method actually beat the moving average by 37%.
This is where it gets really interesting. Why did the sophisticated method fail so badly?
Yeah, explain this to me. I thought smoothing was supposed to be better.
It usually is, but remember the context. The sales were trending up. A moving average includes older data. So when you're predicting for June, it's averaging May, April, and March.
And April and March had lower sales number.
Exactly. Those lower numbers from the past drag the average down. It's like an anchor. The moving average is constantly lagging behind the trend,
While the naive method just grabs the most recent month.
which is much closer to the leading edge of the trend. So in a market with strong, steady growth, the dumber method will often win because it has less lag. It reacts faster.
That is a massive takeaway. Context is everything. You can't just blindly apply the better formula.
It challenges the assumption that you always need to process the data. Sometimes the rawest signal is the truest signal.
So to recap for everyone listening, we've got the naive method, tomorrow equals today. Great for baselines and strong trends.
And the simple moving average, which smooths out noise, great for stable but jumpy data, but it lags behind.
And you have to choose your window size, your N, carefully. Small N for speed, large N for stability.
And finally, never just guess. Use the metrics. Calculate the MAD or the MSE. Don't rely on your gut. Rely on the math.
As we wrap up this deep dive, what's your final piece of advice for someone who has to make these kinds of calls at work?
My biggest piece of advice is never rely on just one method and always test. The text mentions holdout data.
A holdout data.
It means don't check your accuracy on data you've already seen. It's like checking the answer key before you take the test. Take your historical data and hide the last few months.
Pretend they haven't happened yet.
Exactly. Then run your models on the older data and see which one better predicts the data you hid. That's the only honest test.
Trust, but verify.
Precisely. And I'd leave you with one final thought. The text touches on this idea of forecast uncertainty. We often present forecasts as a single number. We will sell 500 units. That's dangerous.
Because it implies we're sure. And if we learned anything today, it's that there's always error.
Right. A forecast shouldn't be a number. It should be a range. We'll sell between 480 and 520 units. That acknowledges the error. It's honest. So in your own work, ask yourself, are you communicating false certainty? Are you reacting to the noise of yesterday? Or are you smoothing out the data to see the real trend?
That is a powerful question to end on. Are you chasing the noise or seeing the pattern? That does it for this deep dive. Hopefully your crystal ball is a little less cloudy now. Thanks for listening.